Solving systems using inverse matrices. Given any system of equations such that a sub 1 x plus b sub 1 y equals c sub 1 and a sub 2 x plus b sub 2 y equals c sub 2, we can write it, we already found out, as a matrix equation. So that would be a sub 1, b sub 1, a sub 2, b sub 2. And multiply that times our variable matrix x, y, and that will equal our solution matrix c sub 1, c sub 2. Okay, so if we denote these as certain variables, we can call this our A matrix, and this is our variable matrix, so x, and then our answer matrix is B. Okay, so if we say this, then A times x equals B. Now, if we wanted to actually solve the system, we can, if we get rid of the A matrix and move it to the other side, then we can solve for x. Now, in order to move it to the other side, we need to multiply both sides by A inverse. If we multiply this by A inverse and this side by A inverse, then that's going to cancel that out to the identity, and we'd be left with x equals A inverse times B. So that's our goal. So we need to find A inverse, and multiply it times our solution matrix. And that's how we solve a system using inverse matrices. So now we're going to go on and do some examples of this method. For this first example, if we find our A matrix, it's going to be our coefficient matrix, which is 4, 7, 4, and negative 2. And so I want to find A inverse. So to find A inverse, I need to find my determinant of A. So that would be 4 times negative 2, which would be a negative 8, minus 4 times 7, which is a positive 28. Negative 8 minus 28 is a negative 36. So my inverse of A is going to be 1 over negative 36 times, switch those two around, the negative 2 and the 4, so it's negative 2. And then the 4 is down in that corner. Add negatives to the others, so negative 7 and negative 4. So now if I actually do my scalar multiplication, then my A inverse is going to be 1 over 18 and 7 over 36. And negative 4 divided by negative 36 simplifies to 1/9. And then 4 divided by negative 36 is negative 1/9. So that is my A inverse. So now if I multiply that A inverse times my B, then I would have 1 over 18, 7 over 36, 1 over 9, and negative 1 over 9. And I'm going to multiply that times my B, which is my solution matrix, 46, 28. So when I actually do that multiplication, I'm going to have 1 over 18 times 46 plus 7 over 36 times 28. And my second row, first column, would be 1 over 9 times 46 plus a negative 1 over 9 times 46. Oh, nope, sorry. That should be times 28, my bad. And then I type that in the calculator and get my solution answer. My solutions would be 8, if you actually type that in the calculator, and 2, which is going to be equal to my x, y, my variables. So therefore, my final answer is 8, 2. Okay, for this next one, again, we find our A matrix. A is equal to my coefficient matrix, 6, 3, -1, 9. And my determinant of A, I know I need to find that too. My determinant of A is going to be 6 times 9, which is 54, minus -1 times 3, which is a -3. So my determinant of A is 57. Once I find my determinant of A, I can find A inverse. So that's going to be 1 over 57 times, switch my 6 and my 9, add negatives to the others. So that gives me 9, -3, 1, and 6. Do my multiplication. 9 divided by 57 simplifies to 3 over 19. -3 over 57 simplifies to a -1 over 19. 1 over 57. And 6 over 57 simplifies to 2 over 19. So that's my A inverse. So to find the solution, A inverse times my B, my solution matrix, so that's going to be 3 over 19, 1 over 57, and -1 over 19, and 2 over 19. That's just copying down my inverse matrix, multiplied by my solution, -24, 23. And I'm going to do my matrix multiplication. So that's going to give me 3 over 19 times -24 plus -1 over 19 times 23 for my first row, first column answer. And then I would have 1 over 57 times -24 plus 2 over 19 times 23. Okay, and then I actually type that into the calculator and simplify everything, and I would get -5 on top and 2 on the bottom, which is equal to my x, y. So my final answer is -5, 2. That's it for your notes over solving systems using inverse matrices. Go through the practice problems. Make sure you get comfortable with doing this method to solve systems, and then you can go on to the final video and then prepare for your quiz.